So on Facebook, I follow a couple of flat Earth groups just for the shits and giggles. And this post came up this morning where they're trying to make this point that rockets couldn't possibly move in space because there's nothing to push against in the background of space. And they analogized it by thinking about like a tire wheel on a car stuck in mud. And if there's no resistance, there's no possible way to move forward, and you just spin your wheels, etc. This is of course completely untrue, and it violates pretty much everything we know about the physics of motion. It violates Newton's third law of motion, for example, which states that for every action there's an equal and opposite reaction. And we can think about Newton's third law, for instance, by saying if there's an astronaut in space and they're on a skateboard and they have a bowling ball in one hand, if they throw the bowling ball, they'll move in the opposite direction. And that's like a roughly speaking kind of good analogy for thinking about how Newton's third law works. Roughly speaking, you need to propel something in the opposite direction to move in the other direction, right? So that's how rockets work roughly. And but I was also thinking about my own quantum gravity proposition and this idea that there's a background electron density in the universe. And this actually gives something for objects in the universe to push against, and it gives something for rockets to push against. If you're imagining, for instance, the Earth is surrounded by a cloud of tunneling electrons, each electron tunnels for a very, very brief amount of time before disappearing again when it interacts with a photon. And there's this kind of invisible, granted, cloud of tunneling particles around all objects. We should actually be able to explain rocket thrust this way, since it actually would be pushing against the background of space. And this makes a bit more sense out of Newton's third law, I think, since if we were to have an astronaut on a skateboard holding a bowling ball and they didn't throw the bowling ball, if they just released it from their hands, they wouldn't go anywhere. They would stay in the same place. So propulsion comes down to a little bit more than just releasing mass from a system. I mean, it's not really good enough just to fire a certain mass out of the back of a rocket and you go forward. It doesn't quite work like that. You still need the specific impulse. You still need the ignition of material, or you need some kind of thruster that's going to fire material out at a given force. That can be like, for instance, compressed nitrogen thrusters in space, or whatever else is used to create thrust on spacecraft. And yeah, I think it does make a lot more intuitive sense to think about the universe being permeated by this cloud of tunneling electrons, since it does provide something for rockets and so on to push against, which isn't just the vacuum of space. And in the atmosphere, we can understand rockets as pushing against the air, which is, I think, a very intuitive way of understanding physics, and not, I don't think, an incorrect way of understanding physics. Since you've got all this material being blasted out the back of a rocket, that basically lifts the rocket up on a column of, usually steam if it's a hydrogen-propelled rocket, for example, or a huge cloud of, carbon dioxide and so on that's being released when it's like a methane fueled rocket and so on. But yeah, it does, roughly speaking, behave in that way. And it doesn't violate Newton's third law to think about it in this way, I don't think. It does update our current understanding of gravity with something which is a little bit more intuitive. So I just thought I'd want to share that today. Thank you everyone for watching. I'll see you soon.